Welcome to the Cal Corporation's series of videos about software engineering. The topic of this video is C++ Destructors. Before proceeding, make sure that you have already watched these other videos first. When this object goes out of scope at the end of this main function body, its storage in computer memory will disappear. But immediately before that memory disappears, its destructor function gets automatically called. A destructor is written using the tilde symbol before the normal class name. A destructor never states any parameters nor return type. If you skip typing the destructor function in your source code, then the compiler will automatically make one for you, which essentially does nothing. For a dynamically allocated object, the delete statement deallocates it. Again, immediately before that memory gets deallocated, the destructor function gets automatically called. It is not an error to use delete on the null pointer. That simply does nothing. When your software has complications, like a class hierarchy, an object's construction and destruction will involve many individual functions because of all the base classes and composition objects that might get involved. In a previous video, we discussed the ordering in which those constructor functions will get done. The corresponding destructor functions will be done in the opposite order. Consider this code. The derived class's constructor has been called, so we should also be calling the derived class's destructor. But we're using delete on a pointer to CR base variable. So destruction would need to be polymorphic in order for the derived class's destructor to get called. In other words, the base class's destructor needs to have been programmed with the virtual keyword. If the base class's programmer hasn't typed any destructor, relying on the compiler to automatically provide an empty one, then the base of that base will determine if destruction is polymorphic or not. Recall that a virtual function can have its own implementation in the base class for those times when the object actually is a CR base object. If that virtual function were pure virtual, then the client code would not be allowed to instantiate CR base, and the derived class would be required to provide its own custom implementation of this function. When we program this pure virtual kind of function, we almost never give the base class its own implementation. Doing so wouldn't make sense. Since we can't instantiate CR base itself, polymorphism will always be causing the derived implementation to get called. So why program any base implementation? But the language does allow you to still program a base implementation. In order to call it, you would need to use this ugly, fully qualified function call. Usually, the only time you'd see that capability being used in C++ code is with destructors. A destructor could be pure virtual, but all destructors are always required to have some implementation, even though that implementation might just do nothing. If low-level software is customizing the allocation mechanism for an object's construction, then that software should probably also customize the memory deallocation too.